Hello everyone. In this lecture, we are going to discuss the topic second translation theorem. It is also called second shifting theorem, second translation theorem, or second shifting theorem. This is actually a translation on t-axis. We know Laplace transform L transforms a function from t domain to s domain, or time domain to frequency domain. So first shifting theorem is a translation in s-axis, and the second shifting theorem or second translation theorem is translation on the t-axis. The statement of the theorem is if L of f of t is equal to capital F of s and a is greater than 0, then Laplace transform of f of t minus a into u of t minus a is equal to e power minus as into f of s, where f of s is Laplace transform of f of t. Then the Laplace transform of f of t minus a into u of t minus a is e power minus as into f of s. Here u of t minus a is the unit step function. We know f of t minus a into u of t minus a is nothing but 0 when 0 less than or equal to t less than a, and it is f of t minus a for t greater than or equal to a. This is the second shifting theorem or second translation theorem. To prove this, we can use the definition of the Laplace transform. We have, by the definition of the Laplace transform, L of f of t is equal to integral 0 to infinity e power minus st into f of t dt. So here we need to find the Laplace transform of f of t minus a into u of t minus a. Therefore, L of f of t minus a into u of t minus a is equal to integral 0 to infinity e power minus st into f of t minus a into u of t minus a dt. We can split this integral to integral 0 to a plus integral a to infinity. We have f of t minus a into u of t minus a is nothing but 0 for 0 less than or equal to t less than or equal to a. That is, as t varies from 0 to a, the value of f of t minus a into u of t minus a is 0. So in the interval 0 a, we have this is nothing but e power minus st into 0 dt, and from a to infinity, this is for t greater than or equal to a, we have f of t minus a. So this is e power minus st into the value of f of t minus a into u of t minus a. On this interval, we have f of t minus a into dt. So this is equal to, the first integral is 0 plus integral a to infinity e power minus st into f of t minus a dt. Now we have to show that this is equal to, this integral is equal to e power minus as into f of s, where f of s is Laplace transform of f of t, that is this. This is equal to f of s. Okay. So here we can replace t minus a by new variable. So putting t minus a equal to some v, we have dv by dt is equal to 1 minus 0, that is dv is equal to dt. Also we have, this is t varies from a to infinity, so t equal to a implies v equal to a minus a, that is 0, and t equal to infinity implies v equal to infinity minus a, that is infinity. So we can replace here integral, this is t from a to infinity, now it is v from 0 to infinity, that is when t equal to a, we have v equal to 0, and t equal to infinity implies v equal to infinity. So v equal to 0 to infinity, e power minus s into t can be replaced by a plus b, that is a plus v, f of t minus a, that is f of v, dt can be replaced by dv. This can be written as integral v from 0 to infinity e power minus sa e power minus sv f of v dv. Now here this integral is with respect to v, so we can take e power minus as outside. So the integral 0 to infinity e power minus sv into f of v dv. So this is nothing but this can be written as integral e power minus s integral 0 to infinity. Here we can replace the variable v by t because this is the definite integral. So e power minus st into f of t dt, because these are definite integral. The definite integral is independent of the auxiliary variable, so we can write like this. So we can replace the variable v by t. So this is equal to e power minus as into f of s. This is the Laplace transform of f of t. So we have a Laplace transform of f of t minus a into u of t minus a is nothing but e power minus as into f of s. This is the second shifting theorem or second translation theorem. Now from the above theorem we can find the Laplace transform of unit step function. Putting f of t minus a is equal to 1. If we put f of t minus a equal to 1, then we have f of s is equal to Laplace transform of this f of t minus a, that is Laplace transform of 1, which is equal to 1 by s. Therefore, by using this theorem, we have L of f of t minus a into u of t minus a is equal to e power minus as into f of s. Therefore, L of u of t minus a, because f of t minus a is equal to 1. So from this we get L of u of t minus a, that is the Laplace transform of the unit step function is equal to e power minus as into f of s. F of s is 1 by s. Okay. Therefore, the Laplace transform of unit step function is e power minus as divided by s. E power minus as divided by s. Now the inverse form of the above theorem is nothing but we have L of f of t minus a into u of t minus a equal to e power minus as into f of s. So from this we have the L inverse of the inverse Laplace transform of this is equal to, that is inverse Laplace transform of e power minus as into f of s is equal to f of t minus a into u of t minus a. That is inverse form of second shifting theorem. Inverse form of second shifting theorem means L inverse of e power minus as into f of s is equal to f of t minus a into u of t minus a, where a is greater than 0 by using this theorem. So we have the inverse Laplace transform of e power minus as into f of s is equal to f of t minus a into u of t minus a, where L inverse of f of s is equal to f of t. L inverse of f of s is equal to f of t. Now we can discuss an example. Find the Laplace transform of f of t equal to 2 minus 3 into u of t minus 2 plus u of t minus 3. So here we have the unit step functions. So we have L of f of t is equal to Laplace transform of 2 minus 3 into u of t minus 2 plus u of t minus 3. By linearity we can write this as 2 into L of 1 minus 3 into L of u of t minus 2 plus L of u of t minus 3. So here we have 2 into L of 1 is 1 by s. So 2 into 1 by s minus 3 into L of u of t minus 2. We have the Laplace transform of u of t minus a, that is unit step function is e power minus as divided by s. So this is equal to minus 3 into L of u of t minus 2. So here a equal to 2. So e power minus 2s divided by s plus L of u of t minus 3. Here a equal to 3. So e power minus 3s divided by s. So this is equal to 2 by s minus 3 e power minus 2s divided by s plus e power minus 3s divided by s. Next example, evaluate L inverse of 1 by s minus 4 into e power minus 2s. So here we can use the inverse form of the second shifting theorem. We have the inverse form of the second shifting theorem. L inverse of e power minus as into f of s is equal to f of t minus a into u of t minus a, where f of t is equal to L inverse of f of s. L inverse of f of s. So here we have to find the inverse Laplace transform of 1 by s minus 4 into e power minus 2s. So comparing to this, we have e power minus as is equal to e power minus 2s. So a equal to 2 and f of s is equal to 1 by s minus 4. So since f of s is equal to 1 by s minus 4, we have f of t equal to L inverse of this f of s, that is 1 by s minus 4, which is nothing but e power 40. We know e power 40, Laplace transform of e power 40 is equal to 1 by s minus 4. So by using this, we get uh, L inverse of e power minus s into f of s equal to, that is L inverse of e power minus 2s into 1 by s minus 4 is equal to f of t minus a into u of t minus a, f of t minus a into u of t minus a. So this is equal to f of t equal to e power minus 4t and a equal to 2. So e power minus 4t minus 2. This is f of t minus a into u of t minus a is u of t minus 2. Another example, evaluate L inverse of s by s square plus 9 into e to the power minus pi s by 2. So to find the inverse Laplace transform of this, we can use this. So for comparing with this, we get a equal to pi by 2 and f of s is equal to s by s square plus 9. So we have f of s is equal to s by s square plus 9 implies f of t equal to L inverse of this f of s, that is s by s square plus 9, which is equal to cos 3t. Therefore, we have L inverse of e power minus as into f of s is equal to f of t minus a into u of t minus a. Therefore, we have L inverse of e power minus as is e power minus pi by 2s into f of s is s by s square plus 9. This is we need to find. This is equal to f of t minus a is pi by 2 here, f of t minus pi by 2 into u of t minus pi by 2. So this is equal to f of t minus pi by 2 is, since f of t equal to cos 3t, we have cos 3 into t minus pi by 2 into u of t minus pi by 2. So this will be the inverse Laplace transform of the given function. Now you can try these problems yourself.